We are going to go over limiting and excess reagents one more time because it is a tricky concept, and I want to make sure you have a good understanding of it. The first type of limiting and excess question would be really practical. We want to determine how much excess reagent we should actually use to make sure a reaction goes to completion. And so our general rule is that we add about 10% more of the excess reagent than is needed based on the stoichiometric calculation. So we still need to do the stoich. We are just going to then determine the actual mass of our reactant number 2 to completely react the 2 grams of strontium nitrate. Once we have the actual mass, we can multiply by 110% to give us that guarantee that all the limiting reagent will be used up. When we set the rest of this equation up, we have a molar mass of strontium nitrate, which is 211.64 grams per mole. We have a molar mass of copper 2 sulfate, which is 159.62 grams per mole. And we start with our measured amount of our given 2.00 grams of our strontium nitrate. We're going to multiply by something to get rid of grams and replace with moles. Again, we're working with strontium nitrate here. So our molar mass that we're going to use is that 211.64 grams per 1 mole. Now we have to multiply by the mole ratio, and in this case it's 1 mole to 1 mole, which is nice. And then we have to get rid of the moles of our copper sulfate and replace with grams of copper sulfate. And so now I have 159.62 grams per 1 mole. When we get that, we have to then multiply by 110%, which is equal to 1.65 grams. So to guarantee that all 2 grams of strontium nitrate is used up, we will use 1.65 grams of copper sulfate to make our solution. That is 10% more than we actually need, but that will ensure the reaction goes to completion. The second type of calculation is a limiting calculation, and this is where we have to determine which reactant is actually the limiting reactant, because we are given the masses or the measured amounts of both reactants. So we have to figure out which one will run out first. Step 1 and step 2, the balanced chemical equation and writing down our given information is the same, but we have to modify step 3 to write a have-need table. Here's our example for our have-need table. We have ammonia, NH3 gas, which is reacting with oxygen gas to produce nitrogen monoxide gas and water vapor. We need to balance this chemical equation. We have 1 nitrogen on the left and the right, so those are balanced. I have 3 hydrogens on the left. I only have 2 on the right, so let's double the ammonia, and then we can triple the water, which means I have to double the nitrogens as well. Now I count total oxygens on the right, and I have 2 from here and 3 from there, which gives me a total of 5. So I need to have 2.5 oxygens. If you're not comfortable using the fractions, you can double everything to have a 4 to 5 to 4 to 6 ratio, but I'm just going to leave the fractions. Now that we have our balanced chemical equation, we're going to write down the information given. We have a mass of ammonia, which is equal to 30.0 grams, and we know the molar mass for ammonia is 17.04 grams per mole. We have a mass for oxygen, which is equal to 40.00 grams, and we know the molar mass for oxygen is equal to 32.00 grams per mole. Now is where the tricky part comes in, the have-need table. We have to determine how many moles of each compound we have. So N is equal to 30.0 grams times by something to get rid of the grams and replace with the moles. And this is for ammonia, so that's 17.04 grams per 1 mole, which is equal to 1.76 moles. I do the same thing for oxygen. N is equal to 40.00 grams times by something to get rid of grams and replace with moles of oxygen, 32.00 grams per 1 mole, which is equal to 1.25 moles of oxygen. Next, we have to figure out how much of reactant 1 I need if I want to react all of this 1.25 moles of oxygen. So we take our 1.25 moles of O2 and we multiply by the mole ratio to get rid of moles of O2 and replace with moles of NH3. And our mole ratio is 2.5 moles to 2 moles. When I do that, I see that I need 1.00 moles of NH3. So I have 1.76 moles of NH3 in my reaction vessel, and I need only 1.00 moles of NH3. I have more than I need. So my NH3 is actually my excess reagent. And how much excess do I have? Well, if I have 1.76 moles and I only am going to end up using 1.00 moles, I will have 0.76 moles of NH3 left over. Now, if it didn't work out this way, we may have had to do the need for the other reactant, which goes the same way. We have 1.76 moles of NH3. We want to use that to determine how much oxygen I need. So I again replace moles of NH3 with moles of O2. Now the mole ratio is flipped, and so I have 2.5 moles of O2 for every 2 moles of NH3, which works out to be 2.2 moles of O2. I have 1.25 moles of O2. I need 2.2 moles of O2 to completely react all of the ammonia. I don't have enough. So that would tell me that this is limiting. Do your need step the first time. Sometimes you get lucky and you find which one is excess right away. Sometimes you have to go and find or end up doing both in order to solve. Now, if we were then asked to figure out the amount of product, we would have to take our moles of oxygen and continue the equation. So we would start with 1.25 moles of O2, and we'd multiply by a mole ratio to replace moles of O2 for our wanted product. Let's say it's moles of nitrogen monoxide. And that would give me a 2 to 2.5 mole ratio. And then maybe I wanted to figure out the mass of nitrogen monoxide, which is 30.01 grams per 1 mole of NO. And then I would get my answer. A second method for determining the amount of a product, if we're given both reactants, is just to go through the stoich for both reactants. So I will show you the second method, and when you are only asked for the product, you can use this effectively. Step 1 and step 2 are still the same. We have to write down our given and wanted information. So balanced chemical equation, AgNO3 aqueous is reacting with FeCl2 aqueous to produce AgCl solid and FeNO3 aqueous. Balancing this chemical equation, we need 2 silver nitrates and 2 silver chlorides to make sure all the atoms are the same. Now, given information, mass of silver nitrate was 18.0 grams. Molar mass of silver nitrate we can calculate to be 169.88 grams per mole. Mass of iron chloride is 32.4 grams. Molar mass is calculated to be 126.75 grams per mole. And finally, we're looking for the mass of the precipitate, and our molar mass of our precipitate is 143.32 grams per mole. So instead of doing a have-need table at this point, we can just do the stoich for both reactants. So starting with our silver nitrate, 18.0 grams of AgNO3. And we don't have to go through all the subscripts, but I will show you on the first one what it looks like. And then we have replacing grams of AgNO3 with moles of AgNO3. We have 169.88 grams per 1 mole. Multiplying by the mole ratio, now we're going from our given to our wanted. So we are going from the silver nitrate to the precipitate, which is what we really want to find in our answer. So that means we are going to use a 2 moles of AgCl over 2 moles of AgNO3 mole ratio. And then finally, we're going to turn that into mass. So we're going to replace moles of AgCl with grams of AgCl. And there comes my molar mass, 143.32 grams per 1 mole. And when I do that, I find out that I will produce 15.2 grams of AgCl precipitate. I'm going to do the exact same thing using this to find the precipitate. So I'm going to skip the subscripts of the compounds just to speed the process up. We have 32.4 grams, and we're going to multiply by the molar mass of iron chloride, which will have 126.75 grams per 1 mole. I'm going to multiply by the mole ratio, which in this case, we're going from iron 1 to silver chloride, 2 moles over 1 mole. Always wanted over given. And then finally, we're going to multiply by the molar mass, 143.32 grams per 1 mole. And when I do that, we end up seeing that we would produce 73.3 grams of AgCl. Now, which one is my limiting reagent? Which one produced less precipitate? Obviously, this one is my limiting reagent, and so this is the one that matters. This one down here was a waste of time, unfortunately, but I didn't know it was a waste of time until I did the calculation. So my statement answer would go something like 18 grams of silver nitrate reacted with excess iron chloride, iron 2 chloride, would produce 15.2 grams of silver chloride precipitate. That was a very long video. Sorry about that. Your practice for limiting an excess is 45 to 54. If you're just looking for the product, feel free to do the stoich for both of the given reactants. If you need to determine the amount of excess left over, the have-need table usually works better.